Welcome back. So I'm Arup Basu from ClusterMicro Technologies. Today we are covering the Java exception hierarchy, the family tree of all throwable objects in Java. Understanding this hierarchy is not optional for OCP 21, okay? The exam will test it everywhere, okay? So in try-catch blocks, method signatures, overriding rules, multi-catch syntax, everywhere, okay? The hierarchy determines three critical things, okay? The first, whether the compiler forces you to handle an exception or leaves it to your discretion, okay? And second, whether a catch block can catch a specific exception, okay? Third, what you are allowed to do when overriding a method that declares exceptions, okay? So let me give you the complete picture before we read the diagram that I have given here. So in Java, anything that can be thrown must be an instance of throwable or subclass of throwable, okay? Throwable is the root of the entire hierarchy. Everything splits into two branches from there, okay? Error and exception. And exception itself splits further into runtime exception, the unchecked branch, and the checked exceptions, okay? So these three categories, errors, unchecked exceptions, and checked exceptions, have completely different rules and completely different exam implications, okay? So let us work through each one, okay? So throwable is the root class of the entire exception hierarchy. It is the only type of object that can be used with the throw keyword and the only type that can be caught with a catch block, okay? So throwable has two direct subclasses, error and exception. Everything else in the hierarchy descends from one of these two. Throwable itself has several important methods that the exam occasionally tests. Get message returns the detailed message of the throwable, or null if no message was provided, okay? Then get cause returns the cause of this throwable, or null if the cause is not set. Then print stack trace prints the stack trace to the standard arrow stream. Then we have toString returns a short description including the class name and detail message. You can technically catch throwable directly in a catch block, okay? Catch throwable T, but this is almost never appropriate in a real code, okay? So first, let us come to error. So we have various kinds of error here: out of memory error, stack overflow error, etc., etc. So error represents serious problems that arise from outside your application, specifically from the JVM itself or underlying system, okay? So they indicate that something has gone fundamentally very wrong at a level that your application code cannot meaningfully recover from, okay? So out of memory error is that the JVM has run out of heap memory. It cannot allocate any more objects. So at this point, there is typically nothing useful that your code can do. You cannot allocate objects needed to handle the situation meaningfully, okay? Then we have stack overflow error. The call stack has exceeded its maximum depth, okay? So this almost always means infinite recursion, a method calling itself endlessly without a base case that stops it, okay? So the rule is don't catch errors. So errors are not checked, okay? The compiler does not require you to catch them or declare them. And you should not catch them because first you usually cannot recover from them, okay? If the JVM is out of memory, catching out of memory error and continuing as if nothing happened is likely to cause more problems. Second, catching error can hide serious JVM level problems, okay, that need to be fixed and not suppressed. And third is the OCP exam specifically tests that you know errors should not be caught, okay? If an exam question shows catch out of memory error E and asks if this is appropriate, the answer is no, okay? Now we move to exception, and we have runtime exception, unchecked, and then checked exception, okay? So exception is the branch that represents problems that arise within your application, okay? Either from incorrect programming logic or from external conditions your code tried to handle. So exception splits into two fundamentally different categories, and this split is most important concept on this entire slide, okay? The split is runtime exception and its subclasses on one side, and these are unchecked. And everything else that extends exception but not runtime exception, those are unchecked, okay? Okay, now let us move to runtime exception, okay? So runtime exception and all its subclasses are unchecked exception. The word unchecked means the compiler does not check whether you handle them. You can call a method that might throw null pointer exception without any try-catch block and without declaring throws null pointer exception in your method signature, and the compiler will not say a word, okay? So these exceptions typically represent programming errors, mistakes in your code that should be fixed and not caught. The philosophy is if you wrote correct code, this should not occur. So you should fix the bug, not just catch the exception. So let me go through each one on the slide, okay? So first exception is null pointer exception. You tried to call a method or access a field on a reference that is null, okay? So that is the most common exception in Java. It means you are using an object reference without checking whether it is null first, okay? So you can see the example here, right? String s is equal to null and s dot length, then null pointer exception, okay? So because you are calling method on null, okay? Second exception is array index out of bound exception. So here you try to access an array element at an index that does not exist, okay? That index may either be negative or greater than or equal to the array length, okay? If you see this example, int arr equal to 1, 2, 3, and then you are trying to call arr 5, right? So it will lead to array index out of bound exception because index 5 you are trying to call and array length is 3, okay? It simply doesn't exist, index 5. So third exception is ClassCastException, okay? So here you try to cast an object to a type that it is not, okay? So here if you see the example that object obj equal to hello, right? And then we have integer I and you are trying to cast obj to integer. So this will lead to ClassCastException because string is not an integer. So this is why you should use instance of to check before casting everywhere, okay? So pattern matching with the instance of in Java 16 plus eliminates this risk entirely, okay? We have already discussed that. Fourth exception is arithmetic exception, and arithmetic error occurred, okay? The most common cause is integer division by 0, okay? So if you see the example here, int result is equal to 10 by 0, so it will lead to arithmetic exception division by 0, okay? So and you have to note that floating point division by 0 does not throw an exception, right? It produces infinity or NaN, okay? And then fifth exception, right? Number format exception. You try to parse a string as a number, but the string does not contain a valid number, okay? If you see the example, intn equal to integer dot parse int within string abc, okay? So this will lead to number format exception. And if you want to do intm is equal to integer dot parse int 42 within quotes, so that will be fine because it will return 42. So this is a subclass of illegal argument exception, which itself is a subclass of runtime exception, okay? So it is unchecked. Now we come to checked exceptions, okay? So checked exceptions are all exceptions that extend exception but do not extend runtime exception. The compiler actively checks whether you handle them, hence the name, okay? The rule is absolute and the compiler enforces it. If you call a method that declares it throws a checked exception, you must do one of exactly two things, okay? And option one is catch it. If you see the example, try file reader fr equal to new file reader file.txt and catch IOException e, then system.out.println file not found e.get message, okay? And then option 2 is declare it with throws. If you see the example here, so void read file throws IOException and file reader fr new file reader file.txt, right? Throws IOException. So if you do neither, so it is a compiler error, okay? The compiler will not let your code build, okay? So why do checked exceptions exist? They represent conditions that are outside your code's control, okay? But then if you write your code properly, then application might be able to handle and recover from, okay? So file not being found is not a programming bug. It is an external condition, as you understand, right? The file might not exist yet, the path might be wrong, permission might be missing, all these things can happen. So these are conditions the caller might legitimately handle, right? Perhaps by creating the file, asking the user for a different path, or falling back to a default, right? So let me go through each on the slide. So if you see IOException, the base class for input output exception, then file not found exception, socket exceptions, and many others, they extend it, okay? It is thrown when an IO operation fails, okay? File not found, connection refused, disk full, stream closed, etc. etc. And then we have SQLException. So it is thrown when a database operation fails. Say you have query syntax error, connection dropped, constraint violation, etc., etc. So it is in java.sql and it is thrown by JDBC operation. Okay. And then we have parse exception thrown when parsing fails. For example, when simple date format dot parse cannot interpret a string as a date. Okay. It is in java.txt. So let me give you the key relationships here. So throwable is the parent of everything. Error and exception extend throwable. Okay. Then runtime exception extends exception. All specific unchecked exceptions extend runtime exception. So all specific checked exceptions extend exception directly. Okay. And not through runtime exception. So why does this matter for catch blocks? So catch blocks must go from most specific to most general. Okay. So if you put catch exception E before catch IOException E, the IOException catch is unreachable. Exception catches everything first. Okay. So this will be a compiler error. So if you see this code here, so it will be quite clear. Okay. Try, then catch IOException E, then catch exception E. So first IOException is E is specific exception, right? So it's specific first and then general after. Okay. Now we come to multi-catch syntax. So Java 7 introduced the multi-catch, catching multiple exceptions types in one block. Okay. So if you see the code here, catch IOException, then pipe, then SQLException E. Okay. The types in multi-catch must not be in a subtype relationship. Okay. So you cannot write catch exception pipe IOException E because IOException is a subtype of exception. The compiler will reject it as redundant. Okay. Because both are same, right? What's the point? So one more critical exam rule is that comes directly from the hierarchy is when you override a method, overriding method cannot declare a broader checked exception than the parent method. Okay. Say you have class parent void do work throws IO exception. Then in the child you say class child extends parent, then override, then void do work throws exception, right? So this will be a compile time error, compiler error, okay? Because exception is broader than IO exception and it is a child who is extending parent, right? So it should not be done like that. So this will be a compiler error. Exception is a parent of IO exception, so it is broader. The overriding method can declare the same exception, a subtype of it, and no exceptions at all. Okay, it cannot declare a broader exception. Say you have class child extends parent and then override void do work throws file not found exception. That will be okay because it will be a subtype of IO exception. And if you don't do anything like no exception at all, like in the second example at the rate override void do work, that is also okay because there is no exception at all. Okay. So this rule does not apply to unchecked exception. Okay. So thanks for your time. Let's meet in the next video.